when we just think up to create a data warehouse, first of all, before we understand data warehouse, let us understand the pain areas of the customers. What was the as is process and what is going to be the to be process. Okay. So in the as is process, customer is having multiple data sources. The company multiple data sources, and those data sources, when I say multiple data sources, it is not a uniform data source. Means the data source is not in a single environment. When I say environment, it is SQL Server or Oracle or any specific database solution.
Okay.
In a SQL Server database, SQL Server, if you have 5 databases, it would not be too much difficult to join to create a data set. In that case, you might not require data warehouse, or you might not think of to invest amount for the data warehousing solution. But when you have the data in multiple environments, one data would be in your say HR data, where we have a payroll, your employee details are there, salesperson details are there, their attendance, salaries, everything is processed over here. Assume that this database is SQL Server. Okay. Another data
Okay.
is basically your core business solution. That's a ERP. Assume that this data is in Oracle. Although it is ERP, here also employee informations are captured. Who is the employee who generates this order? Who is the salesperson who connects to this customer? So those informations are mapped over here. That means with this database to this database, there is some functional relationship. Okay, they are separate database and a separate environment. This is a separate database from a separate environment. Same way, other product data, that means it is a website or e-commerce website where client is placing orders online to purchase your products. Okay, so that database may be a MySQL database. Now there are 3 different databases: SQL Server, Oracle, and MySQL. So when the order is placed over here, what is the next course of action? Order is placed, inventory is maintained, and then someone from the employee who needs to place this, who needs to execute this order. This order will be executed in your plant, and the output will be delivered to the customer to this product portal. In the product portal, then the order will show that the order is going to be dispatched. Okay. Now there are 3 different databases. All these databases are functionally interconnected to each other. Now, how you need to bring them to a single platform for reporting? Will it be advisable to connect from Power BI directly to all these 3 databases? Although Power BI can connect, Power BI or any BI tool also work as a ETL platform. They can connect to multiple database platforms. Through Power BI, you can connect to multiple database platforms. You have to bring them to directly to Power BI, and then in the front end you have to make the functional relationship. You have to make the tables joined. The joining you are doing in the front end. That means the load of the data modeling you are taking into front end. So definitely the reports will not be that much of performing if you have a if you have a data warehouse. There are 3 databases. You take all those 3 different databases. Of course, their database, storage. There are tables. Their field length of the field, their data types, all will be different. So when you just join those tables into Power BI and make a relationship in the front end, it will be too much difficult. And in terms of performance also, that will not be too much impressive. That will be slow. So this is the pain area of the customers. Now, if you would have a single database, it would have you to connect one database. No further data blending is needed. Data integration is needed. You would have simply fetch it to UI. So thinking that the idea of data warehouse has been conceptualized. Okay. Now,
Yep.
before we go for analysis layer, we had to introduce one integrated database. It is not a rocket science, it's a simple database as we have any other transaction database. It can be created in MySQL, Oracle, SQL Server, or whichever the data relational database product you know. But only difference between a data warehouse and a database is a pattern of storing the data in their table.
Okay.
When I say pattern, that pattern in transaction database is called as a OLTP, online transaction processing, whereas in data warehouse it is called as OLAP, online analytical processing. Okay. Now, what is the difference between online transaction processing and online analytical processing? There are a lot of differences. If I will just going to list out those, let me just show you the differences. This is also a question, interview question. What's the difference between data warehouse and database? Okay, I have a database. Database. Okay. Now, first difference is this is a normalized data. Normalized data structure. Just data structure or schema. See, there are nomenclatures are different. You can just call it as a schema or data structure. Schema is a kind of a view or preview of your data structure. Okay. So normalized data structure and denormalized data structure. Now, what is the difference between this normalized and denormalized? The DML, scriptings will be faster in denormalized schema, like data insertion, data updation, data deletion will be faster in normalized schema. That means one table, say employee. Okay, employee has address. In address, you have city, country, state province, and your designation. So all these are the master data, we can say. Now we can just segregate those data in masters and transactions tables. So employee information would be one table, city will be one table, country will be one table, designation would be one table. Likewise, one information of the employee could have been could be split to 6-7 tables. That is a normalized schema. All right. So normalized data here in the database is stored. Data is fragmented into multiple tables. So say few information would have been fragmented to 100 tables in the database. Now, when you go for selection SQL, in that case, it would be difficult for you to join all those scattered tables and to form a single data source for a reporting. In that case, joining in Power BI can be possible, but again that will depend upon the performance. So performance will not be good in that case. So it's better to follow data warehouse where the denormalized schema or data structure is there. That means suppose there are 6-7 table for employee which has been there in OLTP. This is joined here. All those tables will be joined here to form a single table in the data warehouse. So it would be easier for analytics professional to select the data instead of connecting to database. Okay. Here you can find maybe one table or two table, one dimension or one fact table, which will be easier for you to selection and joining also.
Okay.
This is world TP. This data is always being used by some other system. That means it is under connection pool. You can say the connection pooling. So it's a transaction data, so it must be always being used by any application or multiple end users where the data is being inserted. So in that case, it is not a judicial decision to fetch the data from that table. Rather, you fetch the data from a table which is a disconnected database. That means data warehouse at any point of time would not have been used by any end user. It is only the data in the data warehouse is only updated in a midnight where there is no usage of the user or no access to the any end user. For example, my company is a global company. Okay, multinational company. It has a presence across all the countries in the earth. Now I want to create analytics for US territory only or US division only. In that case, should I take the entire data from the OLTP database? No. In US office, we have created a separate data warehouse. In Singapore office, they have created a separate data warehouse. In Russia, they have created separate data warehouse. But the global application is one. The application is a central application. The database is one. So that is OLTP. Whereas we want to create a data warehouse for US only. In that case, I will filter out the data which is only relevant to US territory. That means if there would be 10 millions of data, here it could be only 1 lakh. That is respective to US only. Okay. So I will filter out the data always from the table considering the territory or considering the branch. But
Okay.
in that case, if you fetch the data from the OLTP, from the 10 million table, the indexing, the searching will be done. But here from 1 lakh record, the searching will be done. Where the searching will be faster? Definitely from OLAP, right?
Yeah.
So main that's the benefit. So consider your different companies or different locations would have created their own analytics for their branches for a different data warehouse, and they must be taking the data from a different considering the different branches or divisions. Now the third difference is this is tran- transactional data model. It is transactional data model and it is dimensional data model. The data model is vary here. The table structures are basically considered as a master and transaction tables. In the dimensional model, the table structure is dimension and
Fact tables.
fact tables. This is one of the differences. Data stored in OLTP in real time. In normally when system will be ideal, OLTP will be ideal. The data will be stored in a disconnected approach. That means in the midnight, uh, selection will be done from the OLTP, data will be fetched, and it will be stored in the data warehouse, and then the command would have been written to disconnect the connection. The connection pool will be released.
Okay.
Relational database
Management.
management system. So relational model, relational model, star and
Snowflake schema.
relational schema. So these are the differences, you can say. Relational schema. Here there is no you master to transaction and transaction to uh, master connections would be there. Here the tables are more structured. Star schema and Snowflake schema are there. So let us understand what are the differences over here. Basically, these are the differences. So he from multiple databases, the ETL professional by using the data tool will be connecting to multiple databases and fetching the data to first to ETL data stage. In the ETL side, say in Microsoft SSIS, SQL Server integration service, or any other ETL like Talent or Informatica Power Center, those ETL could be used for data warehousing. They first fetch the data and store the rough data into their data stage, like whatever the data you want. Okay, table 1, table 2, table 3, they will fetch here, store it in their data stage roughly, and then as per the document, whatever the data we need to be pushed to data warehouse, those data will only be segregated and joined here, transformed and loaded into the data warehouse. If they would have selected 100 records, 100 column table, they may enter to data warehouse to 10 or 15 column records. Okay, so that type of transformation they can use. And then while joining the tables from Oracle to MySQL, the data structure, data type also would have been varies. So say in SQL Server, the data type is integer, int. In Oracle, the data type could be big int. Okay, the length of the fields would be different. Okay, so in that case, they must be first converted to a seamless or uniform uh, platform, and then store into data warehouse. So in the data warehouse, it would be treated as you are fetching the data from a single source, irrespective of their data type differences, irrespective of their OEM differences. So this would be much easier. Now in the analytics layer, we simply have to connect to data warehouse. We can connect to multiple databases, but connecting data warehouse would be super easy here. ETL, see ETL, how they ETL also work in a DFT, disconnected approach. Say today they always don't fetch the data here. For creating the ETL transformations, they take the data once. Okay, they store in their rough database called as a staging. Okay, and from the staging they do necessary transformations, joining of the tables, and do the necessary testing. They must be creating a test data warehouse. So they will be running the transformations to take the data from the staging to the test data warehouse. If they would find that the data migration is happening perfectly, in that case only they will point the data migration to live data warehouse. Now, where they will just execute this at the time of development, at the time of development, they would be doing these transformations every time, whatever time they want. They completed one transformation, say selection of the data from Excel and migration to SQL Server. Execute the button, the data will be synced from this side to this side, that side. But this activity is not done on a real time when we perform the migration from the to the live data warehouse. So in that case, this schedules this data integration package. The package once they have created in ETL, they will just in the ETL they have to deploy the package to the ETL server.
Okay.
Suppose for 10 data migration, they are using 10 transformations, and all those transformations are sequenced one after another, and one package is created. This package is scheduled to be executed in the midnight at say 12:30 p.m., 12:30 a.m. in the midnight. So that particular time only the data will be synced from the OLTP to data warehouse. Now, on the day one, they would have fetched the entire 15 years of data from data base to data warehouse. On the day two, they would have written a condition that we will fetch the data of last 24 hours. Yes, this should be too much use, right? When loading the data from 15 years to a data warehouse, that might take 3-4 hours or even more. But when and this is not good decision to always load the same data again and again to data warehouse. Data warehouse we can say archive data. Now when you just load the data in the second day, day two, in that time they will just change the configuration in the ETL to select the data on an incremental fashion. So the data will be selected, only last 24 hours of data will be selected. Time to which time? Say today is 15, tomorrow is 16. 12 a.m. of 15th to 12 a.m. of 16th. Okay, or 11:55 p.m. of 15th. So next night, up to that particular duration, up to that 24 hours of data will be selected from the OLTP and stored in the OLAP, and then the connection will be disconnected. So in the analytics in the Power BI, when the server will be refreshed in the morning, they will be getting the data of latest data in the data warehouse. This is how it works.
Okay.
In the data warehouse, different transformation tools are there. One tool I'm telling you that is called as a slowly changing dimension. In SSIS, one transformation is called as a slowly changing dimension that is used to fetch this data in an incremental fashion.
Okay.
Even though the data is deleted in OLTP, the same data will be deleted in data warehouse. If the data is modified in OLTP, the data will be modified in data warehouse. If a new data is inserted to the OLTP, that particular record will be inserted in data warehouse. So these checks will be done slowly changing dimension transformation in the ETL. So let us see the differences of your database schema, normal OLTP schema and OLAP schema. This is the OLTP schema. Say I do have a supplier table product table, then here table. So this is a customer table. Customer table is a master table, right? It has lot customer informations, and customers are not updated every day. Whenever a customer comes, this customer KYC information is updated here in this customer table. This is a master table, we can see. It's not like every moment the customers are coming into system. No.
Okay.
Now, according to the customer, the data is executed or product is prepared. So customer gives the order. You have certain customer CRM or customer master data. Every day, any customers from that master data only provides you the order. So that order will be executed over here. So this is a transaction table. One customer might give you 100 different type of orders every day. Customers are your clients. The client is giving you orders. You have to execute this order. So this is the transaction table. Every day transaction is order done. Now one order has multiple line items. Like in an order, suppose you go to a restaurant, you have a different data orders. For your table, this one order is created against your customer details. Whatever the items or food and beverage you consume, that will be mentioned, line item details, that we call as a order details. For every item, there should be some unit price, some quantity, some tax, etc. So that detail will be captured here. This is one to many relationship. Now in the order details, product price is there, product ID is there. So what product will be executed, that product information is fetched from the product master here. This is a master table, and whatever it is executed, whatever it is delivered to customer, the payment is tagged to each order. So that's also a transaction table. Transaction happens to order table, order detail, and payment. Every moment this data are getting updated. So whichever the table is frequently updated, that is called as a transaction table. Whichever the table contains the data or metadata and very less often they are updated, this is called as a master table. Here it is supplier. Do you think suppliers are daily basis change to a company? No. Suppliers provide a product. So you maintain certain suppliers, certain in-panel suppliers. You maintain certain products to deliver. That's your company's product. And the product categories also. These are one-time data or very less often they are updated. Okay, understood about this OLTP? This is how the transaction database looks like.
Okay.
Now, same type of data, if you just try to migrate to data warehouse, how does it looks like? Let's see. When you go for creating a data warehouse, we have to also take one more intelligent decision, that the schema or the data structure which we will design, what is the type of schema here? It should be a star schema or a Snowflake schema. So data warehouse has two different concepts: star schema or Snowflake schema. As you see in the picture, star schema is very neat and clean. There should be one fact table in the center, and all the dimension tables will be surrounded across it. Every dimension table will be connected to star schema. The dimension table would not have direct relationship between them. They all will be connected to star schema, to fact.
Okay.
Whereas Snowflake schema is something like, you would have one fact. Across the fact, you would have dimensions around it, and each table are also connected to one or two more dimension tables. Let's see. So this is a very neat and clean star schema. This is a customer table. This is sales table. When we want to create an analysis, I would have a vision to make the analysis of what? What is this dashboard is all about? Is it a sales dashboard or a stock dashboard or a revenue dashboard? Whatever it is, I have to focus on a core area. So my core area is to find out the sales. Here the measure is sales. You can see here sales order number is a main measure or a fact. I would like to find out here. This is the primary key. Sales order number and count of sales order number is my fact here. Count of sales order number is my sales. I would like to find out the number of customers by sales. I mean customer wise sales. Then here this table and this table will be involved. Customer ID key is connected with this customer key. Okay. This dimension table is connected with this fact table by this customer key. This is the foreign key of customer table. Likewise, product key, here is product key. So all the dimension table will be connected to fact table by means of a primary key and foreign key relationship. In fact table, I should have a facts centrally located. Sales order, quantity, unit price, revenue, stocks, whatever you want. Discounts, these are the facts. You have to create the data warehouse based on the order ID. Here you see order table, order ID will be one fact. Okay. And price, order price will be one fact, quantity will be one fact, discount will be one fact. So these four facts I will first merge this table, order and order detail and payment. I'll merge, join and merge these three tables to form a fact table. Okay. Now what I have first in the fact table, I have ID,
You'll have order ID, customer
price,
ID.
customer ID will not be fact. Customer ID is a relationship from the customer.
Yeah, foreign key.
Yes. Order ID here, order ID will be my count of the orders. That's the sales. Order ID will be a fact. Price will be a fact. Quantity will be a fact. Discount will be a fact. Okay. And rest of other unusual fields, I will simply discard, like error log, timestamp, right, shipper ID, record date, etc., etc. I will simply discard. I will only keep the amount or the fact which I want to keep it in the fact table. Okay, one fact table we have created. Now from the customer table, all the details of the customers which I don't want to be used in the chart, I will simply discard. In the customer table, I will only keep customer ID, customer name, customer city, country, etc. That's it. It's a dimension. This customer ID will be connected to my order fact. Here it is order, order detail and payment. I'll merge these three tables to create a order fact or any other dimension. So now supplier will be one, product will be one.
Customers.
Supplier is not connected to order directly. So supplier, product and category can be merged to form a single dimension table and they can be connected to order table. And here customer will be connected to order table directly. And shipper can also be connected to order table. So I have three dimensions. One is shipper, customer. Three dimensions are connected to order fact. Now moving into Snowflake schema. Here it is a sales fact. Suppose quantity, unit price, sales amount, tax amount, total amount is a sales fact. And rest of all are the dimensions. Okay. So how many we have to see how many dimensions are directly connected to fact. So this is a Snowflake schema. I have four dimensions around it, surrounded by this. One is product, second customer, third salesperson, fourth date. Now this product is a dimension table who has another dimension table associated with it, and another dimension table are associated with the this. If you want to make it star schema, now tell me what measures you have to take on this. Four dimensions tables over here: product, customer, salesperson, and date. Right? And one fact table we will have: sales fact. Now you understood how to convert a Snowflake schema to star schema. So in star schema is even more denormalized by than a Snowflake schema. Star schema is highest denormalized, whereas Snowflake schema is somewhat semi denormalized, you can say. It has also some of the normalized information. One fact table must have multiple foreign keys, because even though they are not, the nomenclature is not clearly mentioned, but whichever the table you would have lot of foreign keys that you would identify as a fact table. Lot of foreign keys and some of the numeric values. No dimension should be there. Are you getting any dimensions over here? Is quantity is a numeric value. Unit price, sales amount, tax amount, total amount. These all are the numeric values. And rest of all these things are the foreign keys. Yes. This sales fact table does not have any primary key over here, but it can also have a primary key as well. As you see in the star schema, here we have a primary key over here, but still we have also some foreign keys. These are all the foreign keys, but it has also a primary key. So it might have also for primary key and multiple foreign keys, and no dimensions in the fact table, only numeric values. The primary key, I mean, this is a fact table. These are all the customized table. So data, it's not here. The primary key is not mentioned here, but it is supposed to be actually. Even though it is fact, but how do you uniquely identify the number of sales over here? Sales amount is there. If you just want to see number of sales or number of orders, how do you identify? Sales amount can be duplicated. Unit price can be duplicated. Quantity can be duplicated. Order ID must be there here. So they have not mentioned, but it is must have a primary key over here
Okay.
for uniquely identify the number of sales. So uh, multiple foreign keys and only numeric values considered to be as a measures. They are the fact table. Another dimension table must not have any numeric values. Here you see customer do not have any numeric. Here also do not have any numeric values like that.
Okay.
So these are all the character type of data only used for grouping and to be used by the dimensions. It is called as a Snowflake schema.